Have you ever stared at a sales chart and just wished you had a crystal ball to see what's coming next? Well, you are in exactly the right place. Today, we're basically going to go on a quest to level up our forecasting game. We're moving from simple guesses to some really powerful statistical techniques, so let's dive right in.
Really think about it for a second. How does a big retail company know how much inventory to stock for the holidays? Or how does a financial analyst even begin to predict which way the market is going to move? It's not just guesswork, right? They are using data from the past to make really smart, informed predictions about the future. And one of the most powerful tools in their entire arsenal is what we're going to cover today.
So here's our game plan. We're going to start with the absolute fundamentals. What is time series data, and how do we decode it? From there, we'll level up through 3 different stages of forecasting power, starting with the simplest method and working our way up to one that can handle some pretty complex patterns. And then, at the very end, we're going to put it all together into your own personal forecaster's toolkit, so you know exactly which tool to grab for which job. Okay, before we can even think about predicting the future, we have to get comfortable with understanding the past. And in the world of forecasting, that means getting a handle on time series data. So let's break down what that actually is.
A time series, at its heart, is just data that's been collected over a period of time. That's really it. So if you're tracking how many people visit your website each day, or the monthly rainfall in your city, or, like you see here, your company's sales figures year after year, you are working with a time series. The absolute key, the thing that makes it a time series, is that the order of the data points matters a whole lot.
Now, here's where it gets really interesting. We can actually break down almost any time series into 4 key ingredients. First, you've got the trend. That's the long-term direction. Is it generally going up or down? Then you've got seasonal variations. Think about ice cream sales. They always peak in the summer, right? That's a seasonal pattern. Cyclical variations are kind of like seasons, but on a much longer timeline, like economic booms and busts that happen over many years. And finally, you have the irregular stuff, just the random, unpredictable noise. Our goal with forecasting is to model those first 2, the trend and the seasonality.
All right, it is time for our first level up. Let's start with the foundation of our entire toolkit, simple exponential smoothing. This is one of the most widely used forecasting techniques on the entire planet, and it's because of its beautiful, beautiful simplicity.
Okay, so this is crucial. You have to know when to use this tool. Simple exponential smoothing is your go-to method when your data is just kind of bouncing around a stable average. There's no obvious upward or downward slope, and there are no repeating seasonal patterns. It's built for that flat, horizontal-looking data. And this quote right here perfectly captures the core logic. You see, unlike a simple average that treats every single data point from the past equally, exponential smoothing is a lot smarter. It operates on a very simple, intuitive idea. What happened yesterday is probably way more relevant for predicting tomorrow than what happened 5 years ago. And this is exactly how it does it. The most recent data point gets the biggest weight. We call that alpha. The data point right before that gets a slightly smaller weight. The one before that gets an even smaller one, and on it goes. The influence of that old data just exponentially fades away into the past.
And here is all that magic, but just put into plain English. To get your brand new forecast, you just take a small piece, that's your alpha, of the latest actual data that just came in, and you blend it with a large piece of your old forecast. It's this simple, really elegant way of constantly correcting your prediction based on the most recent piece of reality.
Okay, you've officially mastered level 1. But let's be honest, the world isn't always so simple and flat, is it? So it's time to level up again and tackle a brand new challenge: trends. Exactly. Simple exponential smoothing is great, but it has a huge weakness. It will consistently lag behind any data that's clearly trending up or down. So if your sales are growing month after month, a model that's designed for flat data just cannot keep up. It's always going to be under-predicting, always one step behind. And this is where we need to bring out a bigger tool from our toolkit. This is called double exponential smoothing, or as it's more formally known, Holt's trend method. And this method is specifically designed to handle data that has a clear linear trend. So how does this thing actually work? It's pretty genius, really. It basically runs 2 different smoothing processes at the exact same time. The first one is smoothing the level of the data, which is just like our simple method did. But, and this is the new part, the second one is separately smoothing the trend, or the slope of the line. Then, to make a forecast, it just adds those 2 things together, the current level plus the current trend. It's not just tracking where the data is, it's tracking where the data is going. All right, you've conquered flat data. You have conquered trends.
Now it's time for what feels like the final boss, data that has both a trend and a seasonal pattern. Let's unlock our final and most powerful forecasting tool.
I mean, this is the kind of data you see all over the place in the real world. Think about airline ticket sales. They probably grow year over year, that's the trend, but they also have these huge predictable peaks in the summer and around the holidays. That's the seasonality. To handle this, we need our Level 3 tool, the Holt-Winters Trend and Seasonality Method. Now, before we can use this powerful method, we have to understand a really critical difference. Is your seasonality additive or multiplicative? Additive seasonality means the seasonal swings are roughly the same size over time, so you might add, say, 10,000 extra sales every December. Multiplicative, on the other hand, means the swings get bigger as the overall trend grows, like sales increase by 20% every December. The model you choose depends entirely on which of these two patterns you're seeing in your data.
So what the Holt-Winters method does is it takes Holt's method with its smoothing for level and trend, and it bolts on a third smoothing equation. This new one uses a parameter called gamma, and its entire job is to track and update the seasonal part of the pattern. So now you've got this amazing machine that is simultaneously smoothing the level, the trend, and the seasonality. It's the whole package.
And there you have it. You've officially leveled up from a forecasting apprentice to a master. So now let's take everything we've just learned and organize it into a super clear, practical toolkit that you can actually use.
This right here, this is your key takeaway. It is your decision-making guide. So how do you pick your weapon? First, look at your data. Is it basically flat? Easy. Use simple exponential smoothing. And you only have to tune one thing, alpha. Does it have a clear trend line? Okay, level up to Holt's method. Now you're tuning alpha for the data and beta for the trend. And if your data has it all, a trend and a seasonal pattern, you bring out the big gun, Holt-Winters. And you tune alpha, beta, and a new one, gamma. It's all about matching the right tool to the patterns you see in your data.
So, we have built this incredible toolkit for identifying and forecasting predictable patterns, the trend and the seasons. But do you remember way back at the beginning, that fourth component of a time series we talked about, the irregular random variations? These models have done an amazing job of taming the predictable parts of the future. But the question that's left is, what do we do about the parts that are, by their very nature, completely and totally unpredictable?